In this question, we're going to look at a problem involving the area of a triangle and vectors. So we're told that the area of the triangle ABC is 20. So I'm just going to draw a triangle and label the vertices ABC just to help visualize. So A, B, and then C. And we're given that O to A, so the position vector of A is 1, 4, -2. So I have the position vector for this point here. And then we're given the position vector of B, O to B, is -2, 2, 7. So we have the position vector of this point here as well. Then we need to find the shortest distance from the point C to the line AB. So what does that actually mean? Well, the shortest distance is the perpendicular distance. So therefore, what I'm going to do is go to the point C up here, and we're going to draw a line that is perpendicular to the line AB. So that would be this line here. And that's going to be a right angle. They want the length of that line, so I'm going to call that H. And actually, you can see this as the perpendicular height of our triangle if the base is A to B, like that. So now let's consider how we're actually going to find this length. Well, we know a formula for the area of a triangle in terms of vectors. The area would be equal to 1/2 of the modulus of A cross product with B, where A and B are the vectors of the side length. So they are not position vectors. I cannot use these vectors here as A and B. Okay, I need the vectors between the specific points. So which vectors could I potentially find? Well, I could find the vector going from A to B, okay, because we have the position vector of A and the position vector of B. However, we don't have the position vector of the point C. Therefore, I'm not going to be able to find the vector of another side length. So therefore, I might be able to find A in this formula, but we won't have anything for B. Now, what I could potentially do is go to C and say the position vector of it is X, Y, and Z. The only issue with that is we're introducing 3 new variables. We have no information about this point C whatsoever. So therefore, I don't think that's going to be a good way of approaching this. So actually with this question, we're going to have to go back to basics a bit. Okay, we know the area of a triangle can be written like this, but we also know that the area is equal to the base times the perpendicular height divided by 2. And let's consider how we could make use of this formula, because remember we said the h that we're trying to find, we could call that the perpendicular height of our triangle. So let's try and fill in what we know. Well, we know the area of our triangle is 20. So I'm going to write 20 there. Now our base, if we define our base as A to B, we can find the vector A to B because we have the position vector of both A and B. And as a result, we can find the length AB because we can do the modulus of that vector. So therefore, in place of the base, I'm going to write the modulus of A to B. And then we've got our perpendicular height. Well, that's our shortest distance we're trying to find, which we've called h. So I'm going to multiply by h and then divide by 2. And you can see once I've substituted all of that in, the only thing we're going to have which is an unknown is the h once we've calculated the modulus of a to b. Therefore, we can rearrange this equation here to find h. Okay, we can start by multiplying by 2 on both sides. So that's going to give me 40 is equal to the modulus of a to b multiplied by h, and therefore h, our shortest distance, is going to be equal to the 40 divided by the modulus of a to b, like that. So all I need to do is calculate the modulus of a to b, and we should be able to calculate this value h. So let's get on with that. Or to get that process started, I need to start by finding a to b. So a to b is going to be equal to the position vector of our destination, so O to B, subtract the position vector of our start point, so O to A, like that. So from the question, O to B was defined as -2 to 7, and the position vector of A was defined as 1, 4, -2, like that. So let's go through and calculate that. So for our x component, we would get -3. For our y component, -2. And then our z component would be +9. So we now have the vector a to b. We can now calculate its modulus. The modulus of a to b is going to be equal to the square root of -3 squared plus -2 squared plus 9 squared. And if we pop that into our calculator, we would get the square root of 94. So we now have the value of the modulus of a to b. So we can now go back to our equation here, and we're going to substitute that into my denominator. So from this, we are going to get that 40 divided by the square root of 94 is equal to h. And if we pop that calculation into my calculator, as an exact value, we found that h is going to be equal to 20 times the square root of 94 over 47. Okay, and if we wanted it as a decimal, it would be 4.13 to 3 significant figures. And that would be the shortest distance from C to the line AB.